Let me get voices to stop, please. Okay. Um, so again, with these openers, we have one rational expression equal to the other. So really what I'm saying is one fraction equal to another, and that's when we can cross multiply. Now, I kind of try to not use that language and because exactly what I explained earlier, that once I talk about cross multiplying, students feel like they should cross multiply all the time, but that's not true. Okay, it only applies when we have fractions equal to each other. So really what's happening when we cross multiply is we're just undoing all the division in one step. Okay, another way to approach this is, like I said, just get rid of the division. And I'm going to do that at least with part A. Okay, part B, I'll show you what cross multiplying looks like. But part A, I'm going to get rid of the division. So 3 divided by 4, I'm going to multiply by 4, making that left side 3. The right side, well, that's really 4 over 1, so I'm multiplying those fractions. Luckily, we just spent multiple days working on that. This is 4 times the entire numerator, so that 4 is going to distribute to the x and to the 2, making the new numerator 4x plus 8. And then we're still dividing by 8. So again, I want to get rid of that division. So I'm going to multiply by 8. I get that 24 equals 4x plus 8. And now, I don't have any more fractions, right? This is just a pretty basic equation that you learn to solve in Algebra 1, right? Get numbers to one side, so subtract 8, 16 equals 4x, divide by 4, and x equals 4. All right, so now, basically what I did was cross multiplying, but I did that in 2 steps. Okay, so the cross multiplying just has you getting rid of that division in one single step. And if we look at what happens, right, this denominator of 4 multiplied to that numerator. Well, that's what cross multiplying has us doing, is taking a denominator, multiplying it by the opposite numerator. Okay, and then eventually I did 8 times this 3. So I take the other numerator times the other denominator. And then we just set those terms equal to each other. 4 times 27, that would be 108. 108. So actually, let's write it like this so we just see where it comes from. 27 times 4 equals 12 times 2x minus 1. Okay, so that's what cross multiplying would look like. Again, just getting rid of the division in one step. 27 times 4, that's 108. The 12 needs to distribute, making that 24x minus 12. And I can add 12, so 24x equals 120. And divide by 24 is 5. Okay, so again, how you decide to solve these does not matter to me. Okay, get rid of the division in 2 steps or cross multiply. The cross multiplying is a little bit quicker. But again, I think it's important that if we do cross multiply, we understand really what's happening. And that's just that we're getting rid of the division in 1 step there. Okay, so now we're going to jump into much more complicated equations. Okay, and with these more complicated equations, here's how we're going to approach them. We're first going to factor the denominators completely. Okay, we could factor the numerators, but denominators are most important. We have to state any domain restrictions because a lot of times we might solve and we might get an answer, but that answer is excluded from the domain because of division by 0. So the same way that we are getting restrictions with the expressions is the same way of how we're going to get our restrictions here. You can, and I don't really love this step, we'll kind of explain that later, but we could, with multiple fractions, add them together. So we get a common denominator and add them together, and then we could cross multiply. But I'm not going to always take that same approach. So let's look at number 1 here. We have this quadratic term, and one thing that we could do is we could cross multiply right off the bat. Okay, and actually, you know what? Let's do that here. Let's go ahead and cross multiply. So 16 times x minus 10. And then 4 times this entire quadratic. And then I can distribute this 16, making it 16x minus 160. And then it equals, I'm going to distribute this 4, making that 4x squared minus 32x minus 80. This kind of equation, okay, because now we've gotten rid of the rational part, right? It's not a fraction anymore. Now what kind of equation is this? Okay, what kind of problem is this? What's the largest exponent you see up there? A 2. What's the name for an exponent of 2? Square. What kind of equation do we call that? Quadratic equation. When we're solving quadratic equations, we need one side to be 0. Okay, so I'm going to subtract 16x to the other side, making that 4x squared minus 48x. I'm going to add 160 to the other side, making that plus 80. And now the left side is 0. Okay, so you can see why we've spent so much time, even dating back to last semester, of solving quadratics and solving polynomials. They show up all over the place. Okay, basically in every unit from here on out, we'll continue working with quadratics. Okay, and might have to use quadratic formula, or hopefully we can factor. Okay, and that's what I'm going to look to next. Okay, can I factor this? So I would take out a GCF of 4, making that x squared minus 48 divided by 4, 12, minus 12x, and then plus 20. Well, what's really nice about this is a is 1. So I can factor this really quickly by just thinking about the numbers that add to negative 12 and multiply to 20. Those numbers are negative 10 and negative 2. And since a is 1, I don't need to use a factor by grouping or an area model. Okay, just 4 times x minus 10 times x minus 2 gives me an answer of x equal to 10 and x equal to 2. Now here's where rational equations are sneaky. We still have domain restrictions, and I didn't check those where I started. If I were to go back to the original equation and think about what numbers make me divide by 0, those numbers can't be our solutions. Okay, so from this x minus 10, we get that x cannot equal 10. That's a domain restriction. Okay, from x squared minus 8x minus 20, that needs to get factored because there might be two numbers that make that denominator equal to 0. Okay, so let's figure out x squared minus 8x minus 20. That would be factored to negative 10 and positive 2. So x minus 10, x plus 2. Yeah. So once again, we get that domain restriction of that x can't equal 10. We already identified that. And then this x plus 2 means that x cannot equal negative 2. So that's another restriction. And the reason why this is important is because if we solve and we get one of those answers to show up, but those cause us to divide by 0, that is not really a solution. Okay, so even though we solved and we got 10 to be an answer, If I plug that back in, I'm getting division by 0, which is a problem. And so we would say that this answer, there's a name for these, is extraneous. And I'm not going to, like, if you don't identify and know that word extraneous, I'm not going to take points off on any assessment. We do need to know that 10 is not an answer, though. Okay, it's just the wording that you don't need to necessarily identify. Okay, but extraneous solutions are any answers that we solve for, but if we plug them back in, they don't actually work and don't actually give us a solution. And that happens in this case because of dividing by 0 with 10. Okay, why don't you all try number 2? It will likely work out a little bit different. You're going to get a cubed term somewhere in there and see what you come up with. Okay, after this, we'll take like a 5-minute break. You can be on your phones, and then we'll work on some of the more, they're going to get more complicated rational equations. Okay, but right now I need everyone to try this problem and not just sit there and do nothing. Okay, see what you can come up with. We'll go over it in just a few minutes.